Right. So you're supposed to have the business letterhead, which will include your logo and your business name. So I'm using Subnot's website as an example. He has his logo here. He has his business name. Uh,
Oh, sir. Just a interruption, right? You have to come up with
uh,
your own business name, right?
I didn't hear that.
You have to come up with your own business name, right?
You're supposed to. I'm not hearing you clearly.
You have to come up with your own business name, like from scratch, like original, like unique, right?
Yeah, you're using back the same business that you would have created in
No, no,
spreadsheet.
no, no. On like spreadsheet, like from a spreadsheet, you create like your own business, right?
Yeah.
Okay, and you're not stealing no business name, right?
No. I don't,
Okay, all right, good.
where the
That's all
question
right.
coming from?
No, just one. Okay.
So you need information on the items or the services that you are offering. So a clear section showing the items and services that you're offering. So I'm not gonna fix this ROM up to now. Next, you need information on the promotion. So the membership is basically the promotion. If you want to add any other promotions, no problem. Now you need this link here for the form, and it needs to be clear that this here is a link for the form. So if you put membership form, at least they're gonna know. Or if you have the instructions like this here, so I'm not sure, you should carry this up a little more to remove this space here so that they see the instruction. Click the button below to download a membership form, and when they click on it, they'll be able to get their form downloaded. So for the form, they need to clearly see that you are offering a membership form there. Clearly show your items. Don't make it too small. Make your items look neat. Have an about us and a contact section. So this is his contact section. Now for the email, what you're gonna do, you're gonna make it look the same so that on the link itself for the email, you should see that email address so that they know that by clicking on it, they will get access to the email. And what you can do is like put email, and they will know that this refers to the email of the company. So in that contact section is where you're gonna put that. You're supposed to add appropriate graphics and position appropriately. Now I would have considered the background, as some of you had background images. So graphics like these here that is relevant to your business, you can add them, position them appropriately. You don't need too much, just a few, so that CX you can see that you have the ability to add graphics. Your website needs to be neat. You need a link to the email address and the membership form. That's it. Now these links here, I think CXC is going to be looking for it, because sometime in the PDF they're saying that you need them, but when you check the mark scheme, they're only adding 2 marks for different reasons. But just to be safe, have navigational links. These are the navigational links here. Now you can create your navigational links 2 ways. One is by you can navigate the page, because all the information is supposed to be on this page here. So what you can do for your navigational links, and what you can do, I noticed some, when you scroll down, you don't see this part here anymore. If you can get that part of the website to remain the same, to remain throughout your website, that would be a better design on your website. So as you scroll down, you still see the navigational links to be able to navigate your website. So for instance, this is one example of navigating. If you click products, it will take you to the product section. And if you click membership, it's going to take you to the membership section, and so on. Now, if you don't get that to work, you can create like different pages, different pages, like how the Saints website has their own, whereby I'm getting feedback from someone. whereby when you click on the link, it takes you to another web page. Now, it doesn't matter what's on this page, you just need to ensure that it relates to your business. But CXC might not check it. It's just that we want these navigational links and so basically have it there. So you can either
So,
or maybe for another page. Yes, Wani?
yes, yes, if you have the navigational links, right? They got to lead to, like, all the information got to be on one page and the navigational link got to take you to that page.
Yes, all the requirements inside of this PDF here needs to be on this one page here, on your home page. But what I'm saying, for the navigational links, you just need them at the top here. You don't need them to take you on the page or to take you another page. But it would be better if you can navigate that page. That way, because remember, we have all of our information on that one page. But what I'm saying, if you don't get that to work, as some persons were having a hard time with that, because I think because of how you design the website, then you could create it to take you to other pages, and you put your normal business information on those pages, and so that you can have the navigational links. But try first to see if you can navigate the home page. Did that answer your question, Zubani?
Yes, sir, something like that.
Okay. Just ensure everything is on your home page. Another thing too, ensure that basically we can tell the different sections of your website. So like this is the welcome part, this is the item part. He's doing it because of different shadings. This is the membership part, the contact us. You can see it's like a slightly different black. Do something like that so we can navigate and see the different sections. I think that's everything. Right, so you guys still have some time to make your corrections on the website, but as I always mention, the earlier the better, because the earlier you finish this off, that means the less work you have for IT, because we won't be starting programming SBA for now, as we still have to finish all of the notes. So what we'll be starting today, I already posted all of your notes for this is what we're going to be starting for this term: program problem solving and program design. For this entire chapter, all of the notes have already been posted. What you are doing, you are no longer printing because you're supposed to be writing notes, but you will not be writing all of the notes. What you'll be doing is summarizing the notes. So like for instance, if we discuss this paragraph here, you write down in your books what is the important point from this paragraph here that you need to remember. So for instance, if we read a paragraph, spreadsheet has rows and columns, you can simply write down spreadsheet is made up of rows and columns. Columns are named by letters, rows are named by numbers, something like that. You're summarizing and writing the important points. So that basically your book now becomes like a study guide, so that you can see all of the important information there. So what you can do is, as we're going through class and we're reading the notes, I would recommend you write down at the same time what is important from that paragraph that you think might be important. And if I say something that you need to remember, you should take note of it also. That way you finish summarizing your notes a lot faster. So for those of you who don't have your book or your pen, I'm giving you 30 seconds to attain that. Alright, let's start now. So, as mentioned, we are starting the topic problem solving and program design. There's four other topics that we need to cover. Actually, not four out of three more. There's four topics in total. For those of you who would have checked the textbook, there is problem solving and program design. There is program implementation. Then we're going to learn programming with Pascal and then programming with Visual Basics. So basically, we're starting off with learning how to structure your program, how to design your program, and then we're going to learn how to implement it, how to create that program to basically make it work. And then we're going to learn two applications that we can use to implement that program. One is Pascal and another is Visual Basics. So our first chapter is Introduction to Problem Solving, and our first reader will be Naresh. Can you read the first paragraph?
Software is the name given to a computer program that tells, instructs the hardware how to work. Software therefore includes computer programs that create system or application software. Each program exists because the problem first existed, and the solution was needed to solve the problem.
Good. So hopefully you guys remember this from third form. Our computer is made up of hardware and software. Hardware, anyone remember what's the definition for hardware?
The physical parts of the computer that you can touch.
Very good. Physical parts to the computer. So anything that you can feel or touch on the computer, that's basically the hardware. So the software is basically like the opposite, what you cannot touch, what you cannot feel. So basically only what you can see. But not all software you can see. So basically, you can have the best hardware, you can have the best mouse, keyboard, you can have the best CPU. But if you don't have software, then all of that hardware means nothing, because we need that software in order to run our computer, run all of the hardware. Software is further broken down into two categories. We have system software and we have application software. Can you guys remember was the system software, or what is an example of the system software?
Sure.
What was that, Isaiah? We didn't hear you clearly, Isaiah.
For operating systems.
Operating systems, good. So system software is basically the operating system. So what are some examples?
Like Linux and Mac.
Microsoft.
Right? Linux OS, Mac OS,
Microsoft.
Microsoft is not a system software, it's not a operating system. That would fall under the application software. Does anyone remember the definition for application software?
Software that the user interacts with to get what he wants from the computer.
Get what he wants. Looking for something specific.
So what do you want to use the computer for?
So basically, application software, it carries out a specific task, or it does one task only. So it might do more than one task, but it's only specialized in doing one specific thing that you design it to do. like Microsoft Word, Paint, some music player, and so on. And the system software is what controls your entire computer. It even controls all of the other application software. Now, the reason why all of these programs exist is because we have problems. We maybe we want to we want to edit text, or we want to create a document, we want to create a letter, some problem we have. And that is why programs exist. So when we're developing a program, we basically see or notice a problem, and we try to come up with a solution by means of creating a program to solve that problem. So the next paragraph is solving a problem. Zamani, can you read for us? Zamani?
Solving a problem. You should first develop an algorithm to solve the problem. An algorithm is a sequence of precise instructions which result in a solution. If your algorithm is vague and has conflicting logic, you will not get the correct answer. Problem solving is usually broken into two phases.
Good. So the first step that we take in solving a problem is to create an algorithm. And an algorithm, so you can take that note down in your books. The first step in solving the problem is creating an algorithm. And what is an algorithm? It is a sequence of precise, notice they put that in italics, precise instructions which results in a solution. So basically, an algorithm tells you exactly what you need to do in order to solve the problem. It should not be vague. You should, when you look at that algorithm, you should not be wondering what should I be doing at this step. So basically the algorithm will tell you at step 1 what you need to do, step 2, step 3, step 4, and so on. And at each step, you need to be precise. You need to say exactly what needs to happen, what needs to be done in order for that task to be carried out. I'm wondering if they give you an example. Okay, doesn't seem so. So let's look at the example of creating an algorithm. Or before we go into that, it'd be best if we look at the algorithm phase and then we head into that. So algorithm phase. Trakel, is your microphone working back for you to read for us today? Still not working? Yet every night you're calling Laquana. Tej, can you read for us? Tej? Tashaya?
Yes, sir. For me, want me to read algorithm codes?
Yes.
In the first phase, there are 5 general steps. Clearly define the problem that you want to solve, propose solutions and evaluate each one, select the most reasonable solution, design an algorithm that is precise and well thought out to solve the problem, test your algorithm. You must be sure your algorithm works correctly before you can write a program for it.
Good. So these are the phases or the steps you need to take to create your algorithm. Clearly define the problem. So what is the issue? So let's take for example, um, our issue is that we do not know how to make a peanut butter and jelly sandwich. That's our issue. That is our problem. We don't know. We've never seen peanut butter. We've never seen jelly. We've never seen sliced bread. And so we don't know how to create a sandwich, a peanut butter and jelly sandwich. You'll read the next paragraph, Tage. So we need to clearly define. So problem, I do not know how to create or how to make a peanut butter and jelly sandwich. And that is what I want to solve. Now, two, propose solutions and evaluate each one. So, what are some solutions in solving that problem? Maybe I could do some research as to what bread looks like, what peanut butter looks like, what jelly looks like, or do some research on the internet, or maybe ask a friend, do you know what peanut butter looks like? Do you know what bread looks like? And you check to see which one might be the most effective. So step 3, select the most reasonable solution. Which would be most reasonable? Asking a friend, or doing research on your own, or some other way. So you check to see what is most reasonable. Then you design an algorithm that is precise and well thought out to solve the problem. So after you have done your research as to how you can go about, you think up of ways that you can go about solving this problem, you write an algorithm that would help you to solve it, so that when you follow it, or if anyone is to follow this algorithm, they should be able to solve the problem. And after you would have written your algorithm, you test it to ensure that it is working correctly. And then you can write your program for it. Any questions on this section so far? All right, implementation phase. Tej, are you ready for us?
Can you hear me?
Yes.
Okay. Implementation phase. In this phase, there are 3 main steps. Translate your algorithm using a programming language such as BASIC, Pascal, C, or Visual Basic. Execute the program code. Maintain the program. For now, let's focus on the algorithm phase.
Good. So remember, we have different phases to create our program. The first phase would be to identify our problem. So we basically think of a problem, and that's the problem that we want to solve. We think that we don't know how to create a sandwich, so we decide that is our problem, we want to solve it. Then we go through our algorithm phase. Identify a problem, think of solutions, think of which is the most reasonable or the most viable solution, write our algorithm, test it, and so on. So after we would have finished our algorithm, we now want to implement that algorithm. How do we do that? We basically translate it or turn it into a program. And we can do that by using different programming languages. So we have languages such as BASIC, Pascal, C, and Visual Basic. So this is what I was talking about just now. One of the later topics, you'll be learning how to translate it into Pascal and how to use Visual Basics. C is more for sixth form. So unless you're coming back sixth form, only then you'll be able to get more into C. Now, after you would have translated into a programming language, you execute that program, which basically means you run that program. So like how in database you had a query and you run that query in order to see the results. With your program now, you run the code or you execute the code in order for you to know if that program is functioning. And then the last step now is for you to maintain that program. So over time, you might realize that you can make this part of the code better by maybe shortening it or adding some more advanced feature so that you make the program run better. Over time, you might realize it is crashing often. Why? Because you did some poor design and it crashes a lot, it has some bugs. So you maintain it by fixing those bugs. So let's look at defining our problem. Tashaya, the first paragraph up to number 1.
Defining the problem. When you first analyze the problem, you should specify your objective. That is what the program is meant to do. The following four steps are used to organize and summarize a program objective. You want me to read number one?
Yes.
Specify the output. What kind of output are you expecting from this program? Will this output be one or more numbers, and text, or even a graphic? Is this output in readable form or is it for input to another program? Will it be displayed on a monitor as a soft copy, printed, or stored in a file? Yeah, great.
Good. So when we are analyzing our problem, we need to also determine how we want the output for the problem to be produced, or how do we want to see that output. What do we want to do with that output? So the first step is to specify the output. So if we're doing, for example, maybe a simple algorithm or a single problem definition of maybe solving the problem of not being able to create a sandwich, how do we want the output to appear? Do we want the output to appear as maybe text on a screen, text in a Word document, or text on a printed document? How do we want it? So depending on what the problem is, we might produce the output in different ways. For example, we can also produce the output so that another program can be able to use it as an input and be able to process it also. For example, say for instance now with the same sandwich situation, say you create the algorithm, you create the program, and the output is now in some sort of form that a machine can read it. So for example, you're at a factory and some person, some engineers design some machines, some robots, so that when you create this algorithm to design to create a sandwich, the robot now will accept that output as its input and be able to create the sandwich itself. So basically, you're creating that program now for the robot to tell it how to create that sandwich. So that's how you can specify the output. You need to think of what is the problem, what are you doing with this output, how are you going to use that output, what are you using it for. The next step, you need to specify your inputs. Tariq,
So, so specify the input.
yes,
Okay. If you know what the input is, you can specify the values, and you can specify what values are needed for the input. Data can be captured by an input device, such as a keyboard, transferred from a secondary storage device, or even entered via voice recognition.
good. So in our algorithm, in our problem definition, we can specify how the data is being inputted to solve our to basically carry out the instructions. So you design your algorithm to solve the issue of not knowing how to create a sandwich. How are you accepting the input to be able to follow those instructions to create the sandwich? Do you type on a keyboard and say accept bread, accept peanut butter, accept jelly? Or can you do a voice recognition and tell the machine to pick up the bread, pick up the peanut butter, spread the peanut butter? So, depending on the case, depending on the scenario, or whatever you're implementing, whatever you're designing, you would use different ways of inputting, just as how you would use different ways of outputting that result. Next, we have specifying the processing. Swavian.
Sir, I'm having a bit difficulties. Specify the processing. What processing should be done on the input to get the necessary output? For example, what calculations are needed? Is the processing grouped as a batch or completed in real time as the data is captured? Most
Good.
programs also.
That's it. Thank you. So, the inputted data. How do you want that data to be processed? Do you want that data to be processed right away? So, in third form, you would have learned about data processing. There is real time processing, whereby as soon as the data is inputted, it gets processed. That's something like your computer. As soon as you press a key on your keyboard, it gets processed right away and you see something on the screen. Now, or you can wait for that data to be grouped so that you process that data in a batch. For example, your post office. When a letter reaches the post office, it doesn't get sent out right away. It doesn't get processed real time. It's the post office waits for a batch of letters and then processes all of those letters and then sends all of that letters out. So you could also process your letters in that way. Not your letters, your program in that way. Do you wait for a set of instructions and then carry out them? So, for example, with our peanut butter sandwich, do you set up the machine to wait for all the instructions? Because you might have the instructions: pick up peanut butter sandwich, pick up, no, sorry, pick up bread, pick up peanut butter, pick up jelly, spread peanut butter, spread jelly, and so on. You might have all of that instructions inside of your algorithm for your program. Now, do you tell the machine to process as soon as you say pick up bread to process that? Or do you tell the machine to wait until you say at the ending spread the jelly? You tell the machine to wait for pick up bread, pick up butter, pick up jelly, spread jelly, and then carry out all of that instructions. All depending on the design of your program, what you're creating it for, that is how you would set the processing. That is how you would implement the processing. And the last one, storage. Shamroy. Shamroy, are you there?
Yes, sir. Just lost connection for a while. What do you want me to read now? Number four.
Yes.
Most programs also specify the storage. Determine how the data and even the information or results will be stored temporarily or for future use.
Good. So, what are you doing with the results? Are you going to use it right away? For example, the peanut butter sandwich. Sometimes you might, if you're creating it for yourself, you might use it right away so that you eat it right away. But if you're a factory, you might want to store it for future use. So, what are you doing with that output now? You might package it and seal it up and store it. So, in terms of data now, for example, if you created a program to process data, what are we going to do with that data? Do we need that data right away so that another software or another computer can use it? For example, a weather station, they might be producing data as they scan the surrounding area. What do they do with that data? Sometimes they have to process it right away, but at times they would not delete that data even though they're using it right away. They would not delete that output because they might need it for future use. So in that case, they might tell the program also, when you send this output to this other computer, in order for it to be processed, store the data also so that we can get it back for future use. So depending on the program, depending on the problem, whatever you're designing, you need to think of during that problem defining stage, um, what is the output? How do you want to produce the output for this program, for this problem? How will you be inputting the information, the data? How will you be getting that data into this program? How do you want that data to be processed? Do you want it to be processed at all at once, right away, wait some time and then process? And then what are you doing with that output? Is it temporary output whereby you use it right away and just get rid of it? Or do you need to keep that output for later use? It's basically storing that output somewhere. So maybe you can store it in some sort of Word document file or an Excel file or something. So, chart. Let me start the IPO chart. So, input processing output chart, also called the IPO chart. Shania, can you read for us?
IPO charts are used to identify the input, the information you need to solve the problem, processing, the steps needed to convert the input data to the desired output, the goal of the problem solution. An IPO chart is not actually a chart, but a table with three columns. Each column represents three components: input, output, and processing. The storage component is not usually documented in the chart.
Good. So remember, I hope you guys are summarizing your notes. So the steps that we have above here, the input, the processing, and then the output, that is what is inside of your IPO charts. As mentioned, it is not an actual chart, but basically it is a table with columns, and we put the headings in the correct order that the process will be carried out. So the first step is input, then it will be processed, and then we have our output. So our input It's always going to be information that you need to solve the problem. What do we need? Um, in some cases, it might be instructions. In some cases, it might be the actual values that you need. So, for example, for the inputs, if you're doing a calculation, the inputs might be numbers that you're inputting, or if the numbers are already in a spreadsheet somewhere, it could be instructions. You telling it to go to this spreadsheet and collect the numbers and do this calculation. So you tell it where it is getting that input from to solve the problem. Then the processing again is how you want that data to be processed. Do you want to be processed right away? Um, and how is it going to get you your output? And then the output is your desired results. Notice the storage component is not usually documented in the chart, but it's good for you to know where your output is being stored. So let's look at an example of creating our chart. Um, Next person is Mariah.
To Maria, and she might go work.
Malika.
Okay, example one. You're giving a problem of finding the sum of three numbers. What is the goal or output? What input information do you have? The output or goal is a number which is the sum of the three numbers. The input is made up of the values of the three numbers. What steps are needed to convert the input or puts into the goals or output? The processing requires the input of the three numbers, adding the three numbers together and saving the result as a single number, the output of the sum of the numbers. Notice that the processing column is written in English. The completed IPO chart is shown below. Read the chart, sir.
Just read the next paragraph.
Okay, you can follow an IPO chart by reading each column from left to right. For example, the input column indicates that you input three values. In the processing column, you add the values that were input. In the third column outputs the results of the addition.
Good. The next one is example two. So let's break down our first example. So in this example, we are looking at adding three numbers and getting a result. So for IPO chart now, we have to break down what is the input, what are we doing to process that input, and how do we want the output? How do we want to present that output? So our input is going to be, we are entering three numbers, number one, number two, number three. Now remember, for our algorithm, we need to specify exactly what we are doing. We need to be clear, we need to be precise. So notice under the processing, it says add the three numbers together. Notice it doesn't say add three numbers, because what if four numbers were entered? What if five numbers were entered? Then in that case, it may not know which three numbers in order to add. So, or what numbers in order to add. So, by specifying add the three numbers, the program will know that it is only adding three numbers together. So it would only look for three numbers. How do we want the result? We want it to be, how do we want the output? We want it to be a result of the addition of the three numbers that we would have just processed. Our second example, Laquana.
So, example 2. You are given the problem of finding the average temperature by using maximum and minimum temperature readings. You then calculate and output the average temperature, max temp plus minimum temp divided by 2, then complete the IPO chart is shown below.
Good.
Input once.
So notice their input is max temperature and minimum temperature, two input. And notice the processing here is different from the processing in example 1. Here, the processing tells you exactly what to do. It's telling you the exact calculation. It's telling you in brackets, as you would remember in spreadsheet, brackets are calculated first, BODMAS, that add the max value and the minimum value together and then divide it by 2. Notice it's a clear processing. And then what do you want the output? You want the output to be the average value from that calculation there. Example 3, we have read a number at 10% and output the results. So our IPO chart, we input a number, and for the processing, that result now that comes for the input, the result is going to be that number plus, it says at 10%. Okay, because the bracket here is calculating the 10% and then it is adding it to the number. Or you could simply do this here. And you get your results, and the result is what you want to output. Sean, you could read the last example.
All right. Input the regular price of an item. Calculate the discount amount at 20% of the regular price and also the item's discounted price. Output the discount amount and the discounted price.
Good. So note in all of our examples, we are clearly stating in the input what exactly is being inputted. Numbers are being inputted, the maximum temperature, the minimum temperature, the regular price is being inputted. That is what we want as our input. Now, how is that being processed? We need to tell it exactly once again. The discount amount, we're looking for the discount amount, calculate the discount amount at 20% of the regular price. So 0.02 multiplied by the regular price should give us our discount price. And then the last part here, when you subtract that from the regular price, we should get our discounted amount, our discount price. So in our output here, we have discount amount and we have discount price. Alright, so this is going to be your homework. Complete this for, when is the next class? Friday? Our next class is Thursday. Complete that for Thursday. We'll review it in class. And so in review, today we started a new topic. We're looking at problem solving. So we all know about software, but the reason why we have software is because initially we all have problems, and in order to solve those problems we have created software. Now, when creating a program, we need to create a algorithm. The algorithm is a sequence of precise instructions or precise steps. Right, so I wanted to go through this example with you guys. So now that we finished that, all right, let me review first and then we go through that. Now, a series of precise steps. To create our algorithm, we follow these instructions. We clearly identify the problem that we want to solve. We think of solutions. We think which is the most reasonable or the most viable, which one would work the best, basically. And then we design our algorithm. We state the steps precisely, we test it, and then we implement it. To create our algorithm, we can basically use, or not the algorithm only, but the entire step of that problem definition or defining the problem. We can create an Ipo chart so that we know what is the input, we know how that data will be processed, and how that data will be outputted. So let's look quickly at basically making a simple algorithm. So step one, what is the first step? Our first step is to clearly identify our problem. So if my problem is that I don't know how to create a sandwich. What should I put here? How can I clearly define it? What should I put? What should I type? You're helping me make the algorithm. What should I type?
Creation of a sandwich.
We need to
How
clearly
to
state.
create a sandwich.
First, we need to clearly state our problem. What is the problem?
The creation of a sandwich.
Don't know how to make
We need to be
The problem
clear.
is you don't know how to make a
I
sandwich.
don't know how to create a sandwich.
You don't know how to make a
Inability
sandwich.
to create a sandwich.
Good. So Shamroy is unable to create a peanut butter and jelly sandwich. Clear to the point. He's unable to create a peanut butter and jelly sandwich. Now, the next step, propose solutions. What are some solutions? What can Shamroy do in order to be able to resolve this issue? What he can do? Practical things that he can do.
Watch a YouTube video.
Look it up.
Ask Google.
YouTube. Ask the money.
Fight.
What else?
Ask Google.
Ask Google. God, we have some solutions there. So, say now he asks Google, Google told him how to create a sandwich. Now, he has to design an algorithm now to precisely solve this problem now of creating a sandwich. So, the next step is our algorithm. So, our first step. What can be our first step? So say we went to Google, they told us how to make our sandwich. So we just created an algorithm now to make a sandwich. What would be the first step? We're looking at making the sandwich now. Precise step.
Buy bread.
What is it?
Buy bread.
Buy bread. Very good. Buy bread. What's the next step?
Get peanut butter. Basically, basically get English.
Get peanut butter. Why can we not say get ingredients?
But it's not like clear
That's
and like stating
That's just vague.
exactly.
Right, it's
Yeah.
vague. You need to be clear and precise. So
one.
buy bread, get peanut butter. What else?
Get the
Ketchup.
jelly.
Get jelly. Good. What's next?
Get a knife,
Get
possibly
knife.
to cut the bread.
We buy sliced bread, but that's okay.
Right. Some people like the sandwich is
It could be a butter
triangle.
knife and just
So what's the next step?
Find a kitchen.
Find kitchen.
Take out two slices of bread. Spread jelly.
Sir, you don't think that you should put down. Remember we find in the kitchen, right?
Mm-hmm.
You put down the ingredients and so on like a table or so, because if we're using a robot, right? Get buy bread, get peanut butter, jelly, knife, everything, and find kitchen, right? So it wouldn't be like this robot just has this stuff in the hand, just like that. So I don't think you don't think that you should let one of the stages be that you put down the ingredients.
Very good, Kishan. Very good. I like that. That remember, I'm letting you guys help me build the algorithm, and that's very good because you need to be precise as to what you're doing. Now you just tell the robot to find the kitchen. He could be taking out this two slices of bread on the ground. He could be spreading this jelly on the wall because you're not telling it what to do. So in this case, you can tell it find kitchen, find table, take out two slices of bread on table. We're not even using a plate. Spread jelly on one slice of bread. Spread
Sir, with the knife, right? With the
right with
knife.
knife. Very good. Spread jelly on one slice of bread with knife. Spread peanut butter on other slice of bread with knife. Anything else?
Combine the two breads together.
one slice on top of the other.
Place bread together. How are we gonna place it? Inside out, outside in.
The Place the covered parts of the bread together.
Place sides of bread with peanut butter and jelly together. There might be a few steps that we missed, but this gives you a very good idea as to how you are creating your algorithm. You need to be specific. It's just as Kishan said. Imagine anytime you're creating an algorithm, you need to think as though you are giving instructions as to someone that doesn't know anything. That's why in the beginning I said, imagine a person that doesn't know bread, that doesn't know jelly, that doesn't know peanut butter. And that is why, because most of the time, you're designing the program for a computer. Your computer doesn't know these things. A robot won't know these things. So you have to tell it exactly what it should be doing, how it should be doing, when, where, everything. You have to be precise. Otherwise, your program might not work. It will have bugs inside of it because it will not know how to carry out that instruction. Right. So you guys have a better idea. You should have a better idea now of creating your algorithm. Now, we create a quick IPO chart. So input, processing, and output. So we just be vague for now, cause so what can be your input? What can be our input? Running out of time quickly.
The ingredients.
Again, the person who said ingredients still vague. So bread,
No, I mean, anyways, I didn't mean like actually listing the ingredients. Like when I
peanut
say
butter,
ingredients, I thought, anyways.
jelly, knife. So all of that is our input. What we wanted to do, processing. Well, you get the idea. We can put the steps together here as to how we're gonna process. Basically, like these steps here that we would have created. And the output, what do we want? A sandwich. This is just a simplified version of the IPO chart. Notice once again, they're not using any spaces in the name. They're using the underscore. Or if they're not using the underscore, they're using no spaces at all. So that's something you use, you do regularly in programming. You don't use spaces because you try to make it like one word. So you either use the underscore or you use no spaces. So in order to separate, if you use no spaces, you would use the capital letters. Alright, so as I mentioned, this question is your homework. Please ensure you're summarizing your notes in your books. And if you guys don't have any other questions, you are free to leave. Enjoy the rest of the day.
Bye, sir.
Bye bye.